This is the solution to the fluids review problems number 1001. A Jeep with a ragtop was traveling down the road at 26 meters per second with the windows, doors, and vents all closed. If the ragtop has a surface area of 3 meters squared, then how much force was applied to lift the ragtop up? A ragtop is a roof that really seems used to be cloth-like, but now it's a little less cloth, but it's flexible, so it can bulge and flex up and down in the air. So what am I given? Well, first off, I'm looking at this and I'm thinking about the thickness of the ragtop itself. It's so thin, I'm not even going to consider the height of it. So I'm going to call the height 0 for this one. Inside, well, everything's closed up. So inside the cabin itself, inside of here, there's no air moving around. So that's going to be a velocity of 0. Now outside, the air is moving at 26 meters per second. So the Jeep is actually moving this way. But compared to the air inside the Jeep, it might as well be blowing from left to right across the top of it. And the roof's area is 3 meters squared, not area, squared. Here we go. So what's my strategy? Well, forces come from gauge pressure and area. That much I know. And I know that the force is equal to the gauge pressure times the area. So what I need to do is calculate the gauge pressure multiplied by the area. There are 2 ways we can do it. One is what we call that pressure at depth equation. That has nothing to do with this. So it's got to come from Bernoulli. So the gauge pressure is the difference in the pressures, P1 minus P2. And I'll use Bernoulli's equation to figure that out. And then I'll multiply the gauge pressure by the roof area in order to get the force. All right, so here's what I have. I have the force, and pressure is equal to force is equal to gauge pressure times the area. So I'll set up Bernoulli's equation, looking at all the variables on the inside. That's the pressure inside, 1/2 rho V inside times squared, plus rho G H inside. Pressure out, that equals pressure outside, plus 1/2 rho V times the velocity outside squared, rho G H. Well, I said the thickness of the roof really doesn't matter, so the height's going to go away. That's where the zeros come from. And the velocity inside is equal to 0. So this velocity here, that 0 there. So that goes away. And then I'll rearrange these so the inside pressure minus the outside pressure, I just need to know the difference. That's equal to 1/2 rho V squared. Now I'll put in my numbers, 1/2. I'm going to use the density of air to be 1.29 kilograms per meter squared times the speed squared. And when I do that, I get 415.05 pascals. So that is the gauge pressure. And the gauge pressure times the area is going to give me the force. So gauge pressure times 3 meters squared, and I get 3110 newtons.